Our topic is series and parallel connection. So series and parallel connection of inductances. So here this is very important concept. Okay, so series and parallel connection of inductances. So first we are going to see the series connection. Of inductances. So we know that the inductance is always represented with L. Okay, now see here the question or the problem number 1 is, if two inductors, so this is the symbol of inductor, we already know about the symbol. So for example, we are assuming that this is the L1, this is the inductance L1 and this is the inductance L2, or inductor L1 and inductor L2. For example, I am considering this is the terminal A and this is the terminal B, and we already discussed about how to identify the series connection and parallel connection in the previous videos. Okay, just to go through the videos, you will get how to identify exact series connection and how to identify exact parallel connection when all these elements are connected in the circuits. Okay, now see here, now L1 L2 both are connected in series. Now to find, actually the question is find the total equivalent resistance. Okay, so find the total equivalent or total equivalent, sorry, not resistance, inductance. So the question is find total inductance. So find total inductance. Now we know that the procedure for resistances and procedure for inductances is always same. It means when two inductances or when two inductors are connected in series, or when two resistances are connected in series, in order to find the total inductance or total resistance, we can directly add all the inductor values. Okay, because in case of series connection, we can directly add all these values in case of resistances and inductances. But in case of capacitances, when two capacitors are connected in parallel, in that time we need to add directly. Okay, so about the calculation of capacitors which are connected in series and parallel is already explained in the last video. Okay, now coming to this topic, actually what is our question? Find the total inductance for this particular connection. Okay, now we know that when inductances are connected in series, then the total inductance, that is LT represent the total inductance, is equal to L1 plus L2. Okay, for example, the value of L1 is, for example, 2 henries or 2 millihenries. The value of L2 is, for example, 8 millihenries. Then to get the value of these two, we can directly substitute the values here. So 2 millihenry plus 8 millihenry, that is equal to the total inductance is equal to 10 millihenry. So like this, we are going to find the value of what? When two inductances are connected in series, we can directly add inductance values like this. For example, if I am going to consider another problem, for example, the problem number 2. Now see, for example, this is the terminal A. One inductance is connected like this, another inductance is connected like this, and the third inductance is connected like this. And for example, the 4 and 5 inductances are, for example, connected like this. Just see here. So this is L1. For example, I am taking the value of this one is 1 henry and this one is L2. For example, this is the value of L2, 2 henries, and this one is L3, 3 henries, L4, 4 henries, L5, for example, 5 henries. Now see, L1, L2, L3, L4, L5 all are connected in series. How we can identify the series connection exactly? To identify the series connection, I can say that I will give you one hint. Okay, when the current is flowing in the series connection, current is always same. Okay, for example, the current is flowing like this. For example, current is flowing like this. It means this current direction is always same and without any interruption. Yes or no? From this point to this point, the current is directly flowing without any interaction. So this is possible in complete series circuit only. For example, if I am going to connect one inductor from this point like this, for example like this, then this current will divides in two different branches. Yes or no? So that is the reason why in pure series connection current is always same. We can also identify the exact series connection of any element. We can use this clue. Okay, now see here, in this problem all are connected in series means, so whenever we are going to find the value of total inductance from this type of problems, so we can directly add all the values. So total inductance is equal to L1 plus L2 plus L3 plus L4 plus L5. Now here the value of L1 is 1 Henry, this one is 2 Henry, 3 Henrys, 4 Henry and 5 Henry. Now here the total inductance is equal to 1 plus 2, 3, 3 plus 3, 4, sorry, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. It means the value of this one is what? 15 Henrys. Okay. So like this we need to proceed to calculate the value of total inductance when all inductances are connected in series. Okay. So this is the procedure we need to follow. Now coming to the parallel connection of inductances. Okay. Now coming to the parallel connection of inductances. So I am telling you the series and parallel connection of any element, resistor, inductor, capacitor is very, very important. Without knowing all this, it is not possible to go for the analysis in electric circuits. Okay. Now coming to the parallel connection. Now here the parallel connection of inductances. So here L represents the inductance. Okay. Now here we are going to discuss about the parallel connection of inductances. Now for example, one inductance is connected like this and another inductance is connected like this. For example, two inductances are connected like this. Okay. Now for example, we are assuming this is the terminal A and this is the terminal B, and here L1 is equal to, for example, 10 Henrys, and here L2 is equal to, for example, 20 Henrys. Now the question is find total inductance. Okay, find total inductance. So here LT represents the total inductance. So these two inductances are connected in parallel. Okay, the two inductances are connected in parallel means to calculate the value of total inductance LT. Okay, to calculate the value of total inductance LT, always we need to take the reciprocal of every element. Okay, now here the calculation. So calculation of total inductance is required. Now here the reciprocal of total inductance is equal to the reciprocal of L1 plus the reciprocal of L2. Okay. Now here 1 divided by total inductance is equal to the value of L1 is, we know, that is what, 10, plus the value of L2 is how much? So directly we can say that the value of 20 is given for L2. Now simplify, 1 divided by LT is equal to, now by taking LCM we can directly write 10 into 20. Now here 20 plus 10. Okay. Now here 1 divided by LT is equal to 10 plus 20 divided by 10 into 20. But we required what actually? We required only LT. We require total inductance value. Okay, so that is the reason why what I am doing, I am taking in reverse to get the value of actual LT. Okay, so the total inductance is equal to, so 10 into 20 divided by, yes, so 10 into 20 divided by 10 plus 20. Okay, so by solving this you will get the value of, so 2 1s are 2 means 200, that is 20 into 10 means 200 divided by, you will get 30, that is equal to 0 0 cancel, then LT is equal to 20 divided by 3 Henrys. So this is the total value of inductance when these two are connected in parallel. Okay, that's why what we are going to do, when we have the value of or when the inductors are connected in parallel like this, so we can directly use this formula. So what is that formula? So total inductance is equal to product of L1 L2 divided by addition of L1 plus L2. So if you know the value of this is 1 Henry, if you know the value of this is 2 Henries, then with this formula we can directly substitute. So 1 into 2 divided by 1 plus 2, that is equal to 2 divided by 3 Henry. So this is the value of total inductance when all are connected in parallel. Okay, for example, what I'm doing, for example, if suppose we have 3 inductors are connected in parallel. Okay, 3 inductors are connected in parallel. For example, here I'm taking another point, that is this is L1. For example, another inductance, this is for example L2, and this one is the L3. Okay, now for example, this is assume terminal A and this is assume terminal B. Okay, for example, the value of L1 is 10 Henries, the value of L2 is for example 20 Henries, the value of L3 is for example 30 Henry. Now the question is find total inductance in the above problem. Okay, for example, question is given like this, then how to find the total inductance? Just now I told you, when inductances are connected in parallel, then we have to take the reciprocal. Okay, reciprocal means what? 1 divided by total inductance is equal to 1 divided by L1 plus 1 divided by L2 plus 1 divided by L3. So by substituting all these values and take LCM and simplify, you will get the value of what? Total inductance with the help of this formula. Okay, so with this procedure is correct. For example, what I am doing, when we are going to simplifying like this, sometimes some of the students are doing some mistakes, because taking LCM and simplifying, some of the students are making some mistakes. That's why what I am doing for those type of students, so first you have to take these two. For example, I am telling you, first you have to take these two inductances and get the value of those L1 and L2. For example, what? So for example, I am considering only the value of L1 and the value of L2 I am taking. Now how to get the result of these two? We know that 1 divided by LT is equal to 1 divided by L1 plus 1 divided by L2. Okay, now here 1 divided by LT is equal to 1 divided by L1 is how much? 10 plus L2 is how much? 20. Now 1 divided by LT is equal to 10 into 20 is a LCM, and here by simplifying you will get 20 plus 10. Okay, now see here, now again simplify here. So this is the actually 1 by LT, but we required what? Only LT. So LT means take reverse. So here 10 into 20 divided by 10 plus 20. Okay, now if you are going to simplify, you will get 200 divided by 30. Okay, 0 gets cancelled, and 20 divided by 3 Henries is the value of what? Only these two inductances. Now what I am doing, I am getting I got the 20 divided by 3 is the result of the parallel combination of L1 and L2. Now what I am doing, I am substituting this 20 by 3 Henry instead of this parallel combination of L1 and L2. I am redrawing the network like this. For example, so see, this is the actual value of L3, that is 30 Henry. Now here this value is the resultant of this parallel combination. So that's why here the total LT is equal to 20 divided by 3. Okay, now see here, now both these two are connected again in parallel. Now here we can say that when two are connected in parallel, to get the value of total inductance, just now I told you, so no need to go for again reciprocal. You know that when two are connected in parallel, product of these two divided by addition of these two will gives the value of what? Total inductance. Okay, that's why what I'm doing. So here 20 divided by 3 into 30 divided by 20 divided by 3 plus 30. Okay, so by simplifying this, so 3 tens are, and here, so total inductance is equal to how much you're getting? So 200 divided by, so 20 plus 3 threes are 90 divided by 3. So that is equal to, so 600, because this denominator of a denominator term is comes to the numerator, then 3 twos are 6. That is why, so that's why 600 divided by 110. So here 0 gets cancelled. Then the total value LT is equal to 60 divided by 11 henries. Okay, so this is the value of total inductance for this parallel combination of 3 inductances. Okay, so this is the procedure we need to follow whenever we are going to simplifying the series connection of inductances and parallel connection of inductances. Okay, so please do subscribe my channel for more updates, and please share with your friends. Thank you so much for watching.